Welcome to CommercialDrones.fm, the podcast that explores the commercial drone industry, the people who power it, and the concepts that drive it. I'm your host, Ian Smith.
Hey everybody, and welcome to Commercial Drones FM. Today I'm sitting this very early morning, I'm sitting in Las Vegas, Nevada at the Commercial UAV Expo with one Mark Blacklin, who's the Data Integration and CAD Supervisor at a company called CGRS, a construction, engineering, and compliance service company for the petroleum industry out in Colorado. So welcome to the show, Mark.
Thanks, Ian. Thanks for having me.
Absolutely. So we are here at the Commercial UAV Expo in Las Vegas, Nevada, but a quick funny story is that I think this is the second or third time we actually tried to do a podcast recording, and you were actually the first guest ever on the show.
Quite the compliment.
Yeah, totally. But unfortunately, in the beginnings, there was a few technical issues in the recording process. So we're finally here in person, recording locally, which is always better. And we don't have to remember that trying time over the internet when we were trying to do an episode. So thanks so much for coming here to be part of the show. And now that is out of the way, so first of all, Mark, can you tell us, what do you do at CGRS? What does a data integration and CAD supervisor do?
So my main focus as data integration supervisor is making sure that all of the data that comes into the company goes from field to finish, as we call it. For everything that starts out, whatever data that comes in, I'm responsible for making sure that it transitions through the company and gets into a finished product that go out the door. A large part of that is computer-aided design. So we take our construction plans, we get customers come in the door, they want to design a fuel system or something of that nature, and I'll make sure that the design happens and it goes all the way out to something that they're happy with, and then we inevitably end up building as well.
Nice, okay. And so obviously, Commercial Drones FM, we're on a drone podcast. So how did you get into drones, and how do they kind of fit into that workflow at CGRS?
So as part of our workflow, we were looking for something that would help us capture aerial imagery as well as topo data on our projects, where we needed to be able to go out, document with the imagery the state of the sites that we're building, as well as do some preliminary surveys for grading plans and that sort of thing with the topo data. Started using drones really on our own projects, and then it transitioned into a business market for us as well, where we now sell those services to other clients.
Nice. And what was, so before drones, like, BD, what were you guys doing before that? I mean, I'm assuming that this was like, standard surveying practices,
right? Maybe
even hiring out a crew sometimes, or did you guys do it all in-house?
No, we hired out the surveying to third-party survey companies. We still do to some extent, depending on the needs of the survey. Doing things like meets and bounds, that sort of thing. We still hire professional land surveyors to do that.
Did you say meet?
Meets and bounds, like boundary surveys.
Sorry, I'm kind of hungry. Okay, boundary surveys. Okay.
Yeah.
So the drones actually, they don't do everything, right? Like
right.
You just mentioned that sometimes you have to hire, another survey crew.
Yep.
What are those instances? Like, when do you find that maybe a drone is not the best tool for the job?
Typically, when it comes to topo and aerial imagery, the biggest factor there is size of the project. With the limitations of line of sight, we found that even going to a fixed wing aircraft really doesn't help us a whole lot, because you still need to keep that fixed wing line of sight the entire time. And if you're lucky, you're getting 2,500 foot distance off of that before you start losing it. So multi-copter is still, for us, the way to go. So you start getting up there in acreage, and we start finding diminishing return, where we start looking at conventional fixed-wing aircraft to get the surveys done for us.
Yeah, I've seen some data that actually backs that up too. Like, you would be surprised at how many, for agriculture, for example, the average farm size in the U.S. is about 440 acres. And so you would think that you would need a fixed wing drone for that, but actually there is a shocking amount of people out there that are using drones on their fields for 440 acres, but just doing multiple flights with the multi-rotor drone, and it's just more convenient. It's quicker, even though you have to change the battery, and continue the mission. Cool. So what kind of like specific missions, like if you could be kind of a little more specific, like with the drone? So you guys are using drones for specific projects, but what are those projects? Like building something petroleum related?
Well, not necessarily. So we flew one for a client here recently where they were doing a land development, and they'd done some preliminary grading of the site and wanted to be able to come back in and check the contours. It was on a pretty steep hillside, 120-acre site. We went out, flew it one morning for them. Took us, I think, right around an hour to fly it. Captured all the imagery as well as topo data. They had PLS set the benchmarks on the site, about 6 or 7 of them for us. And we, had great results on that, high accuracy, quick turnaround of the data. And the client was really, really happy with what we were able to provide, and in the time frame that we were able to provide it as well.
When you say topo, so a lot of people say that, and so some of the listeners might not know fully what the topo means. So what exactly, when you refer to something as a topo like data set, what exactly is that?
So for our clients, most of the time what they're looking for is our contours, vector contours of the ground surface. Sometimes we'll send off a point cloud of the data. That's not as common these days just because of the bulkiness of that data set. It's so many points on these projects that the softwares are able to create nowadays. We don't typically send those unless it's specifically requested. Digital surface model, digital terrain models is another format as well. But most commonly, we're seeing that the clients want contour data, in either the 6-inch or the 1-foot interval.
Okay, cool. So contours are those kind of lines that, will be in intervals as the terrain rises. There'll be a line every 6 inches, and then if you look at that from, a 2D perspective, you can kind of tell the lay of the land,
exactly,
as it were. So why are the contours actually important? Like what kind of usage is that? What value is that for the end user, end client in these projects?
So the contours enable the client to compare it to existing. They probably went out ahead of the project with a conventional survey, went in, checked the ground conditions, and now they can go back in and see from the contours they're able to, in civil computer-aided design packages, build three-dimensional surfaces of what the real world is. So they're able to replicate that, if you will, in a digital sense, and then do all sorts of analysis on that. They can check where water is flowing. They can check volume calculations on piles, elevation differences between where it was the ground originally was versus where they have either cut or filled into that area, and just make sure that the grading plan is as they designed.
Yeah, at my full-time job over at Drone Deploy, we've seen a lot of demand for contours.
Yep.
So those are very, very important. You did mention, I think you said that mission that we were talking about earlier was kind of on the side of a mountain, or something like that.
Yep.
Like
Steep terrain.
Yeah,
yes.
And you're in Colorado.
Yes.
So maybe, what are some lessons learned, actually? I think this is interesting. First of all, at the UAV Expo, I met about 4 people in the span of, a few hours, and all of them are from Colorado. So I don't know if it's because the flights from Colorado to Vegas are cheap, but there's a lot of Colorado folks here, and there's a lot of, maybe you have aspirations to operate a drone and you do live in hilly terrain or mountainous terrain. What are some lessons learned when operating a drone for mapping missions in that type of terrain?
Be careful, first off, because that terrain will come up on you really fast before you know it. It's a tricky one, and it really requires some forethought on the mission planning side of things as to how you're going to handle the flights. whether you're going to take off from the low end of the project, the high end of the project, if you're going to step the missions, if you're flying it just in one mission or multiple. There's a lot of different parameters that come into play and what you need to be looking at in order to have a successful mission.
And ideally, you want to have all of the images taken, if you're using this for photogrammetry, all the images taken at a uniform altitude above the ground.
Correct.
So as the ground is undulating beneath the drone should ideally be following the terrain.
Exactly.
And adjusting its altitude. So sometimes that can be hard to accomplish if you don't have the correct software that just tells the drone what to do.
Just flies flat a lot of the time. Yep.
Yeah, and then you'll have alternating resolution on your final data. So that's not desirable, but I'm sure sometimes it kind of has to happen.
Exactly.
Yep. Okay, cool. So what kind of hardware do you guys use at CGRS to accomplish these drone missions?
We're currently flying the DJI Inspire 1 Pro with the larger camera on it. And we've had really good results out of that platform for the types of needs that we have.
And it's the X5 or the X5R.
Correct.
I guess
the
you
X5.
don't need the R.
No, it just shoots in RAW format.
Yeah, that's more for like video stuff. And, okay.
High bit rates.
Nice. So what else do you guys use? Do you guys use any type of like total station or like GPS stuff for ground control?
Our ground control units, we're a Trimble fan. We use a unit called a Geo7. It's centimeter accuracy, so highly accurate. Not as good as a RTK unit perhaps, but still high enough that it gets us the data that we need and the accuracy that we need on these projects, and our clients have been really happy with it. So that GPS is definitely a requirement as far as setting ground control on these projects.
And what could one expect to spend on such a GPS unit?
I think the prices are coming down every day, but on a Geo 7, I think you're looking in the neighborhood with the antenna and everything, probably close to $20,000.
Okay, cool. Not too cheap, but hey, if you want to get accuracy, then you gotta pay the piper. So I do know that in some areas you can rent those on a daily basis. So
correct.
If you are starting to get into this, but actually, I should advise, if you're going to start using ground control points and start calling this survey work, you better be careful what you call yourself in your business, because there are actually state laws that will prohibit you basically from calling yourself like a surveyor, because you have to be a licensed surveyor in order to do that.
Yeah.
So
anyways, that varies state by state.
Yeah, so be careful with how you represent yourself, and just be cognizant of the fact that there are professional land surveyors out there that might not be taking too kindly
correct
to that. Okay, great. And so what kind of software let's switch over. So you mentioned accuracy. You have to get this accuracy. Why is the accuracy important? And when you say accuracy, what do you mean?
So it's important to note that there's a difference between accuracy and precision. Accuracy is accurate to the real world as to what an elevation, and this is, most important for us is the vertical control, the elevation component. We can already get really good accuracy in the horizontal, in the XY. With the imagery, but the vertical, the contour data, the digital surface models, that's where it really comes into play. It's more difficult to get that accuracy, and so having a good survey unit, having good ground control point layout is critical to ensuring that accuracy is there in the project.
Speaking of ground control points, we're kind of taking this theme of accuracy and running with it now, but I think I remember. So you've learned quite a bit, I think, from your usage of drones and doing photogrammetry from the air with GCP's ground control points. I hear this question a lot. It's like, how many ground control points do I need? And I think there's a point of like diminishing returns. If you set like 50 ground control points on an area, you've just wasted a lot of time.
You might as well do a conventional survey at that point.
Oh, yeah, exactly. So what have you found? Is there like a sweet spot? I mean, like for a given area, how do you go about figuring out where I need to set ground control?
So we look at the lay of the land, how much terrain is there, and as far as determining what ground control you need, I liken it to a blanket flapping in the wind. The more points that you can help to tie that down within reason, the closer you're going to replicate the ground underneath it. So if you can do 4 corners and the center point, you're probably in pretty good shape. If you sprinkle a few more across the middle of that blanket, you're going to be really, really good. Now, if you put, like you're saying, 50 of them across that blanket, you're diminishing return. You don't need that many, but each project is different, and there's no good way to say, okay, well, on 100 acres, you need 6 ground control points. Every project is different. Accuracy needs vary. Projects vary, and it's really impossible to say, exactly how many you need on any given project.
I'm really digging that metaphor. I'm like smiling and nodding profusely on the other end of the mic over here. That was really good. So I think that'll help. Some people might not even be actually familiar with ground control points. So would you mind telling us, like, what's the process of setting ground control? I mean, we did talk about that GPS unit, very expensive GPS unit. Maybe I'll just let you take that and run with it. Like,
sure.
If you're explaining to someone who's very new, how would you kind of tell them about ground control points?
So ground control is a method of tying the photogrammetric image processing to the real world known coordinates. So in the typical workflow, what we would see happen is you go out before you even fly any area. You go out and you choose these ground control point locations. You lay an aerial target, something that's visible in the drone or the UAV imagery when you're flying, preferably a high contrast target of one form or another. Again, before you fly, you'll go out and you'll survey those points so that you know exactly where they lie. Then you can go ahead, fly your mission.
That's when you use that GPS unit.
Correct.
So you drop the point on the ground, and then you come with that stick, the really expensive stick with the little little disc on the top that gives you really accurate GPS. So the reason why you use that stick, of course, as well, is because it's so much more accurate than the GPS that's on most drones.
Correct.
Okay, cool. And so you get the stick, and then you stick it on the ground control target, and then you record the GPS data onto a SD card?
Exactly, yeah. Okay. XYZ location, where that target is in the real world. And then when you go to process the data after after you've flown the mission, you can go ahead and assign those ground control points to known places. So you can pick out an image and say, okay, I can see that target in this image, and I know that this image is at this exact location in the real world. And that is essentially that pin on the blanket, if you will, that helps tie the digital model down to the real world coordinates with high accuracy. Like you're saying, it's not as good. The GPS on board the UAV is not as good as what that survey grade unit can get and can obtain for us.
True that. So are you excited to eventually use, and I know that these are pretty expensive now, but some drones do have RTK GPS on board, which in some cases can not necessarily negate the need for ground control points, but actually make it so if your accuracy tolerances are a little bit more looser than others. Like, I mean, you can get 5 centimeters of accuracy.
Sure.
Are you guys planning on maybe using any RTK equipped drone systems in the future?
Our workflow at the current time says that we use ground control points, known surveyed ground locations, because what we do is we'll include checkpoints on all of our projects as well, which are points that are surveyed but not used in the image processing. So the RTK on board can help speed up the image processing because it knows precisely where each picture was taken. But as far as the data, we always want to ground truth, as it were, where the data is on the ground. Make sure that we have known locations and verify that against the processed data. So the RTK on board, I think it's a powerful tool, and like you say, used in the right circumstance, it's going to be helpful. It's going to be beneficial. But for us in our workflows, we always want that ground truth happening.
So about software then. So we talked about hardware now, and that was really just awesome explanations across the board. What kind of software do you guys use to accomplish your missions? I mean, maybe from like A to Z, like starting the mission. I mean, what does the software suite kind of resemble at CGRS?
Do we want to get into specifics here, or?
Just, I guess, like whatever you want to talk about, like, okay, yeah, we kind of use this for flight planning sometimes, or we use this for processing, and then like maybe what you finally do with, once you get the data and you have to like kind of post-process it, or if you do anything like that.
Yeah, so typically our flight planning app that we're using with the Inspire is Drone Deploy. We found them to be definitely the most robust and most reliable flight planning app out there. We've tried a lot of the other ones and just can't get the stability that we get with Drone Deploy.
We did not plan this, by the way.
No,
anyway.
no, this isn't a shameless plug for Drone Deploy. It's just the way our workflow is.
What you actually use, yeah.
Right. Next up for image processing, we actually use Pix4D in-house. Gotcha. And that's really just for ease of including ground control points at this point. We've used Drone Deploy online and had good results there, but we don't have the control with ground control. It's a little trickier to have that data included. It's not that it's impossible. It's just a little more legwork, if you will.
Yeah, and you guys really need as much flexibility and control as possible.
Exactly.
So for your operation, yeah, it makes
it's just the way to go.
Complete sense to use Pix4D, of course.
Once we have the data outputs from Pix4D, which most commonly, like I said earlier, is the aerial imagery and the contour data, we bring that into a package called Autodesk Civil 3D, which is a computer-aided design program, and do our final work and grading plans and watershed analysis, all that kind of stuff.
Your domain.
Yes, and that's my world. That's civil design. That's where I'm happiest. Been doing that now for almost 15 years.
Do you have like a super crazy workstation computer that you use?
Yeah, I've got pretty high-end laptop that I actually do most of my work on. A nice. Dell laptop that's last year it was one of the biggest, baddest ones they make. And then our processing computer is pretty robust as well, all liquid cooled and fancy nice. That way. So it's a nice setup for sure.
Very nice. Cool. Great. So let's see. We've covered a lot of these topics here. So maybe we can talk about specific, or as specific as we can get, ROI. So the return on the investment that you guys have seen. I mean, there's three general ways that I kind of think about it. Like, okay, time saved, money saved, and then increased safety.
Right.
Have you experienced any of those three while using drones on the job?
We've seen in some form or another, we've seen all three of them. Maybe not simultaneously all on one project, but to some degree, we've seen them all. We've seen the cost savings definitely as far as speed that we can gather data on a site. We've seen the safety when doing volumetrics on large piles where we're not sending somebody scampering up the side of a loose pile, doing volumetric analysis and trying to survey a pile. We're really seeing it all in one form or another.
Nice. Do you guys see, or how old is CGRS, the company?
We are 29 years this year. We started in 1987.
Nice. Are you guys a startup? It's funny because like, when do you stop being a startup? I don't even know. Like, anyway, so do you see? So the point of that was, do you see your drone usage rising as time moves on?
Definitely. Our drone use is in its infancy right now, as I think it is across the board, not just for us, but the entire industry obviously is in its infancy and growing every day. I can definitely see the day when drones become another tool in the toolbox where they are basically checked out or used. Okay, I've got a project coming up next week and we've got all sorts of different equipment at our company that we check in, check out, and the drone's going to be another tool in the toolbox. Much like a shovel is these days, you're going to sign out a drone and take that to the field and do your work with it.
Nice. And what's the most exciting thing happening right now in the drone industry? I mean, we're past Part 107. I think when we initially recorded that first episode that was never aired, we talked about, I'm excited for Part 107 and everything. Okay, whatever. Who cares? Part 107. FAA did a great job. So looking forward, I mean, what's the most exciting thing happening right now in the drone industry to you?
Gosh, there's so many different facets right now that are moving forward at lightning speed, it seems like. Sensor size is a big one. I'm seeing these LiDAR pucks coming down in size, getting more to the point where you don't need a big S1000 to haul the things around. That's going to be an interesting progress to see that happening.
Do you guys use LiDAR currently, or
no? We don't, but we've definitely had requests for it. And typically, what's happening is our clients request it, and then they say, "No, thanks," when they hear the price. The cost benefit just isn't there yet. But as these sensor sizes shrink, typically the cost is coming down with that. So it becomes more and more realistic to try and start using those in a UAV platform.
And so those the appeal of LiDAR is because it's like ridiculously accurate. You don't need ground control and everything.
Yep. And you get multiple returns on the data, whereas with photogrammetry you only get the first return, so you only get the top of a building or the top of a tree. With LiDAR you can get first and last returns, which is the bottom, the ground underneath the tree as well, which is really helpful when it comes to doing digital terrain models or digital surface models.
So it penetrates like the foliage.
Exactly.
Oh, wow.
Yep.
Okay, that's really cool. Nice. That sounds cool. You were going to say something else, I think, before I cut you off about LiDAR. I wanted to touch on that before I forgot.
Oh gosh, I'm not sure. I'm at a loss.
Okay, you're not
now.
Excited about anything else except LiDAR. Well, so you're attending the show as an end user of drones?
Right.
Okay, cool.
Yeah, we're interested to see the sessions and really learn how other people are applying them. We know in our own little world what's happening and how we do things. We talk with the customers who are wanting to get going and wanting to fly their own. But this is really an industry that we want to check out how other people are doing things. What are we missing, or what can we share with our process and learn from each other here?
Awesome. That's awesome. Cool. Well, it looks like it's going to be a great UAV Expo. So, Mark, thank you so much for joining me here. I'm so glad we got to do this in person. We're finally going to get to air our conversation. This is one of the ones I was just so excited for, because if I ever have any questions or need to pick someone's brain that's an expert on surveying and, using CAD software and stuff like that, my first person I turn to is Mark. So really appreciate you being here. It's been a great chat. I think a lot of people are going to learn some stuff on this. And you can go ahead and, as a listener, you can go ahead and check out cgrs.com/UAV, and you can kind of see the webpage that CGRS has set up for their clients to see how they operate and what kind of stuff that they do and offer. And you can follow Mark on Twitter at @MSBlacklin. That's Mike Sierra BLACKLIN. And of course, while you're at it, you can go ahead and follow the podcast at Drones Podcast on Twitter and Facebook.com/Drone Podcast. Go ahead and leave a review or a comment, or send us an email. Tweet us, find out maybe some more questions that we can get answered by Mark. So, Mark, thank you once again.
Thank you, Ian. Thanks.
All right. Fly safe, everyone. Cheers.